first utility function that would represent the reference of the consumer would be that of perfect complements. Now, perfect complements is a sort of a utility function which would refer to two goods which are perfectly complementary to each other. What does that mean? I would always purchase the two goods X and Y in a certain ratio. For example, good X is left shoe, good Y is right shoe. Okay. You would only be able to enjoy a shoe if it is a complete pair. If I have only the left shoe, the shoe is absolutely useless. If I have only the right shoe, the shoe is absolutely useless. If I have the left and the right shoe, then only will it give me any utility. So these are examples of perfect complements. Tea with sugar, tea is one of the good, sugar is the other good. Pen with refill, pen is one of the good, and the refill in the pen is the other good. So these are all examples of perfect complements. Okay. The utility function is usually given in the following fashion: ax comma by, where x is to y will be in the ratio b is to a. So utility minimum of ax comma by, x is to y is in the ratio b is to a, will be represented by a utility functional format as this. So whenever you hear from the examiner that the goods X and Y are consumed in a certain ratio in which X and Y will always be consumed is an example of a perfect complement utility function. So whenever I come to know that the preference of the consumer is such that X is to Y is equal to a constant, I will go into the example of perfect complement, and the utility function will take this kind of a functional format. Okay. Now, since I know the utility function, let's now try to understand how will the indifference curves be. The indifference curve of a perfect complement will look like this. X is to Y is equal to B by A. So Y is equal to A by B into X. Okay. X is to Y is equal to B is to A. So Y is equal to A by B into X. That's this line. This is my X. This is my Y. And the indifference curves will be L-shaped. Okay. Every indifference curve giving me a different level of utility. So all combinations here of X and Y give me the same utility. Similarly, all combinations here of X and Y give me the same utility. Okay. The vertical or the horizontal part, you can think about it in this way, that if I have two left shoe and only one right shoe, I will be either in the vertical or the horizontal part, depending on whether I take the left shoe or the right shoe on the horizontal axis or the vertical axis. Okay. Right. So it'll, if I take the left shoe here and the right shoe here, then 2L comma 1R will be on the horizontal axis. Similarly, if it is one left and two right, I'll be on the vertical part. See, if I have two left and one right, I basically have only one complete pair. Okay. So whether it is 2L, one right, or it is one left and one right, it will give me the same utility. Right. So the horizontal part is the extra amount of X that I have, but I don't have enough Y. Similarly, on the vertical part, I have extra amount of Y, but less amount of X. Hence, even if I increase my Y, it leaves my utility unchanged. And here I am increasing my X, it's leaving my utility unchanged. Okay. So perfect complement works in this kind of a fashion, and the indifference curves is of this type. Now, if I couple this with affordability, like for example, if I consider the budget line as M is equal to XPX plus YPY, which gives me an absolute straight line downward sloping like this, no prizes for guessing where the optimal consumption of X and Y will be. Given this blue budget line, the highest indifference curve achievable is that of U1, and the consumption for the consumer will be at this kink point of the L-shaped IC. This is the amount of X consumed, and this is the amount of Y that the consumer will consume. Okay. So X naught, Y naught is my optimal consumption in the case of U is equal to minimum of AX comma BY. And if I have a perfectly linear budget line like this. Okay. So in the perfect complement case, It's actually very simple. I will consume at the king point. Am I understandable? If I am, then please raise your hand. This is how you deal with perfect complement case. However, there will be different cases where it is not a straightforward perfect complement case. Like, for example, you will get examples like ax plus by comma cx plus dy. Okay, then this is not the usual perfect complement case. And we will consider a few examples in order to understand how to deal with such cases as well. But that we will do once we go into a problem. Okay, but in general, the perfect complement case looks like this. We get L-shaped ICs and the solution happens at the king point. Okay, it's very easy to see because if I consider this as the budget line, the highest indifference curve achievable is this U1. U naught is at a lower utility level. Given the budget line, which is the highest IC achievable, it's U1. All right. So this is about the perfect complement case, and examples I have already shared with you: left shoe, right shoe, tea, sugar, pen, refill. Is there any other example that any of you would want to share? I'll be happy to hear it from you.